Welcome, grade 11. We're going to look at some revision for the June paper 1. I took the questions from the November 2015, but it will be for the actual June revision of algebra. In specific, we're going to look at numbers and equations. So if they ask you, solve for x in the following, if this is not possible to factorize, then you will make use of the formula. But otherwise, we try our luck with normal factorization of a trinomial. 12 we can break up into 3 times 4, and the difference between 3 and 4 will indeed be positive 1. I'm going to say I have 4 and I minus 3, then I have 1. Remember, there's a negative at the end, so that means that the signs must differ, and they do differ, a plus and a negative. So from here we can say x plus 4 is equal to 0, or x minus 3 is equal to 0, so x is equal to negative 4, or x is equal to positive 3. Please jump this step. You don't have to write that out. All right, next one. If I see a square root in an equation, what must we do? There's a few guidelines that I want to give you. If you see a square root in your equation, then step 1, you get your square root alone. Step number 2, you're going to square both sides. And why do we square both sides? Because we want to get the square root alone. And step number 3, you're going to test your answer. So with the first one, the square root is already alone. Step number 2, we're going to square both sides. And very often, if you forget step number 3, you will lose like 2 marks, because sometimes, you know, the answers will not be applicable. Right, so let's square both sides. Now, a square and a square root will cancel out. So then we sit with 2x plus 1. If you are scared that you're going to forget how to FOIL, then rather write the bracket out twice. Otherwise, if you're sure you will remember, you say x times x is x squared. I owe 1x and I owe another x, so I owe 2x. And a negative 1 times a negative 1 will be a positive 1. This now becomes a trinomial because there's a square. So it will be x squared, I owe 2x, and I owe 2x, I owe 4x. You see what I do? Because it's already a plus on the right side, I'm just taking everything over to the right side. 1 minus 1 will be 0. Please don't think that you can just cancel out the x and that's it. No. Whenever it's an x square, you must remember that it becomes like a quadratic equation. And then what do? You set equal to 0 and you factorize. So to factorize this, I'm going to take 1x out. So x minus 4 will remain. Then you can say x is equal to 0, or x minus 4 will be equal to 0, therefore x is equal to 4. But we're not done. We must test the answer. You don't have to show the testing. I always tell my pupils, if you work out and you write down the testing, then hopefully you will not forget it in the exam. But if you just do it on the calculator, we tend to forget. So what you do, which, as I said, which you can do on the calculator, the left-hand side must be equal to the right-hand side when you sub in the answers. So you can also do it in your head if it's not a tricky one. So if x is equal to 0, it will be 2 times 0, which is 0, plus 1, which is 1, and square root of 1 is 1. sub x is 0 in here, then it's 0 minus 1, which is -1. And 1 is not equal to -1. Therefore, where x is equal to 0, it will be not applicable. It won't be our answer. Let's test where x is equal to 4. At the left-hand side, this will be 2 times 4, which is 8, plus 1 is 9, and square root of 9 is 3. If you put in x as 4 here, it will be 4 minus 1, which is 3. And because 3 is equal to 3, x is equal to 4 will be a valid answer. But then, because the 1 wasn't, you'll have to say, therefore, x is equal to 4. The next one, I see exponents. Now, whenever you see an exponent, you must know the exponent guidelines, and you will find the summary on the website. The first thing we do when we see an exponent is we break down into prime numbers. And then you must know what is type 1. Type 1 is when there's only multiplication in the sum. The type 2 exponents you recognize when you see a plus or a minus in between. And type 3 is what I refer to as type 3. That's when you see an equal sign. And I see equal sign here. Now with type 1, I always like to say what you must do. If it's type 1, you multiply only. If it's type 2 and you see a plus and a minus, you have to look for a common exponent and then you take it out. With type 3, you take the x's to the left side. Take the x's to the left side. And then you try and make the bases the same and then you can drop them. Or you try and make the exponents the same and then you can drop them. So if you look at this one, we sit with a 2 to the power of is equal to 2 to the power. So it means my bases are the same, so I can drop them. So now we can just write x times square root of x, which is equal to 27. What will I do with this? Well, I'm going to change the square root. Now take note, I'm not getting rid of the square root. You get rid of the square root like we did in the previous one when you square both sides. But I'm not going to square both sides because I don't want to get rid of the square root, but I do want to change it. So how do you change something? Is when you divide the exponent with it. For example, if it was a 4 square root of x to the power of 12, then you can divide the 12 with 4, then it will be 12 divided by 4, which will give you x to the power of 3. Now with this one, there's the invisible 2 in there, and the exponent of the x is 1. So I can change it by writing it as x to the power of 1 divided by 2. So this will be x to the power of 1 times x to the power of 1 over 2 is equal to 3 to the power of 3 because we break down 27 into a prime number. You multiply the bases, therefore you add the exponent. So this will be 1 plus a half, which is 1 and a half. 1 and a half we can write as 3 over 2. And then to get your x value alone, we're going to multiply both sides with a reciprocal. So let me show you. I'm going to multiply with 2 over 3 on both sides. So you multiply the exponents with 2 over 3, because that's basically 3 over 1. You see, because you need to solve for x. So then x will be equal to 3 to the power of, you cancel this out, 3 to the power of 2, so x is equal to 9. Here we sit with an inequality. Now, inequality also has its own guidelines. Inequalities. Because of inequality, you treat as if it's an equal sign. You're going to set everything equal to 0. And then we're going to factorize. As I said, it's like a quadratic equation. You're going to factorize. With inequalities, you also have to find the critical values. And it's like being in ICU. 50% chance you will be fine or not fine. So we're going to look at the critical values to decide on which side are we going to work. Now, to explain that, if you sit, for example, with x is smaller than something, you always interpret it from the x. Smaller than, I explain it to my pupils, I say you are still small. So you see this as a closed mouth. So you're still small. So we will be looking at the values on the inside between the critical values. Some teachers explain it just with a line. So if it's smaller than, it will be an open dot. And if it's smaller or equal, it means you will just color in the dots. If it's where x is greater than, again, my way of explaining, I like to teach using stories or pictures. If it's greater than, it means you interpret it from the x, and that's a big open mouth. So you are big. You're allowed to go outside your house. This parabola is your house. So it means you will go outside, and we look at the values on the outside of the critical values. So let's solve this. This is not too difficult factorization. Please never say your answer here is equal. The critical values you always do here on the side where no one sees it. I'll tell you now why. So if you break this up, if you factorize this, it's 4 times 2. I need to owe 2, so it means I'm going to owe 4 and have 2. Now to solve that, you will say x plus 2 is equal to 0, or x minus 4 is equal to 0. So x will be equal to negative 2, or x will be equal to 4. So now we must decide, is it going to be on the left side or the right side? But before that, why can't x be equal to negative 2? Just want to explain it to you. If this is your sum, let's say x is equal to negative 2, then this is going to be negative 2 plus 2, which is 0. And 0 times anything will be 0. And you can't say 0 is smaller than 0. It's impossible. So that's why it's either going to be a number smaller than negative 2 or bigger than negative 2. We will have to decide. Now, years and years ago, there were long ways of figuring this out. But now the teachers and the textbooks are giving you guidelines. I would say shortcuts to figure it out. So the shortcut here is smaller than. So it means we're going to look at the values on the inside. It's just a shortcut, and then we will test to see if it's working or not. So if that is negative 2 for the shortcut, there's negative 2 and there's 4. So x is smaller than, so we look at the values on the inside. Or if you work with your lines, then it means you won't include the values. Whenever x is in the middle, you write the answer with x. I mean, if the values are in the middle, you always put x in the middle. So x will be smaller than 4 or bigger than negative 2. Let's say you sit an exam and you're not sure if it must be on the right side or the left side, because remember now it's 50% chance that you are right or wrong. So you can test and make sure. So we expect if x is on this side, for example, 5, the answer should be wrong. Or if you want to work with -3, the answer will be wrong. So let's quickly test here. This is just for you. You don't show the examiner. You just show the examiner that. And show the examiner your drawing. So if I must test where x is 5, I expect my answer to be wrong. Meaning the answer won't be smaller than 0. Let's see if I put in 5 there. Already I see a 5 minus 5 will be 0. And this is 7. And 7 times 0 is 0. And 0 is definitely not smaller than 0. So we know those answers won't work. But let's see if the answers in the middle will work. Let's take an easy one. For example, where x is 1 will lie in the middle. So let's see if we test quickly where x is 1, because you want to make double sure your answers are right. But you don't always have to test. This is only if you're not sure in the exam. So if x is 1, my answer must be smaller than 0. 1 plus 2 is 3, multiplied with -3, and that's -9, which is indeed smaller than 0. Let's look at this one. We must solve for x, and they say correct to 2 decimal places. Now, if they say that you must solve something correct to 2 decimal places, then it implies that you must use the formula. So we have to make use of the formula. X is equal to minus b plus or minus b squared minus 4ac over 2a. So what is your a value? Your a value is 5. The b value is 6. And the c value is -7. So I'm going to sub in x is equal to negative, b is 6, plus or minus, and then it's b squared. So it's going to be 6 squared minus 4 times a, which is 5, times c, which is -7, over 2 times 5, which is 10. I normally like to simplify the inside. I suppose I should have done it here where I have more space. So if you do it on the inside, it's going to be -6 plus or minus 36. Negative is a positive. That's going to be 20 times 7, which is 140 over 10. Let me continue there. Now you're going to work it out. And the first answer that you are going to get, if you pop it into the calculator, working with a plus, is actually going to give you -3 plus 2 square root of 11 over 5. Now you might be tempted to think, oh, that must be the answer. This would have been the answer if you had to leave it in simpler surd form. But they said round off to 2 decimals. So then you must press the SD button where it converts it to a decimal, and you will get 0.7266, etc. Rounded off to 2 decimals, so you must look at the third. So you will just round it off and show it like this, to 0.73. Or you do the other one, and then you're going to sit with -3 minus 2 square root of 11 over 5, SD it, and you will get -1,9266, etc. So x will be equal to -1,93 if you round off to 2 decimals. Right. It then says here, hence, hence always means that you must work with the previous answer, work with the previous answer, or in this case, we're going to work with the previous concept, work with a previous answer, meaning we have been working with the formula. And if we need to figure out the nature of the roots, we work with the discriminant. So the moment that you see roots, it means that you are going to work with a discriminant. So I just want to show you the three types when we work with the roots. Now, with nature of the roots, you will find a summary on the website that you can download, nature of the roots. And if you look at my summary, there's 3 columns. Right on the left side, it's where the discriminant is bigger than 0 with its 2 categories there where we're going to look at rational and irrational roots. In the middle one, it's when the discriminant is equal to 0. And on the right side, I've got a column where the discriminant is smaller than 0. Now with smaller than 0, it's when it's non-real roots. More of this when you look at under the section nature of the roots. And these 2 will be when you sit with real roots. So yeah, we're going to look at the value of d for which this trinomial has equal roots. So for equal roots, it means that we're going to look at the middle column where the discriminant is equal to 0. Right, so we're going to, and that's where the hence comes in, because we're looking at the discriminant, which is the b squared minus 4ac. So we're going to set the discriminant, work with it. Again, what is your a value? The a value is 5. The b value is 6. And the c value will be everything that doesn't have an x or an x squared. So the c value will be negative d. So b squared will be 6 squared minus 4 times a, which is 5, and the c value, which is negative d. And we are going to set this equal to 0. This then will be 36, negative negatives are positive 20d. So negative 36 will be equal to 20d. And then you divide both sides by 20. So d will be equal to negative 9/5. Simultaneous equations. The simultaneous equations in grade 11, you sit with 2 equations where most often you only sub in the one into the other one, where you often just have to get your x or your y value alone. They sometimes just give it to you in a fancy way where you sometimes have exponents, where you first have to do exponential equations and then it becomes simultaneous equations. Now, when I do this, I know many teachers would write it underneath each other. I don't. I normally just write it next to each other. In this way, I know that I won't sub in the wrong one into the wrong one or the same one into the same one. So I'm going to get my x value alone. And when you change something, you just give it a new name. So now it's equation number 3. Then I'm going to write here that I'm going to sub equation number 3 into number 2. So I sit with x times y is equal to 20. So in the place of x, I'm going to write negative 3 plus 2y multiplied with y. Distribute the y in, so it's negative 3y plus 2y squared is equal to 20. So what now? It becomes a quadratic equation. So we're going to say 2y squared minus 3y minus 20 is equal to 0. And let's see if we can factorize this. 2 consists of 2 times 1, and 20 consists of 10 times 2. Or what can you do? You can swap around into 2 times 10. And if 10 times 2 doesn't work, you try 4 times 5. So let's quickly see if we can factorize this. And you need to find a difference of 3 when you factorize. This will give me 4 and 10, so that won't work. 20 and 2 won't work. 10 and 4. And if you swap it around, it's also not going to give me a difference of 3. 10 and 4 again. So now, unfortunately, we have to make use of the formula. X is equal to minus b, and there's a catch here. So please pay attention. Minus 4ac over 2a. So it's minus. Be careful here, because the b value is already a negative. That's your first catch. B squared, so it's going to be negative 3 squared minus 4 times a times c over 2 times a, which is 2 times 2. I sometimes like to simplify it just so that I know there's less chances of making a mistake. So then this will be 9, and this is negative, and a negative is a positive, and that will give me 8 times 20, which is 160 over 4. Now, if you carry on working this out, you are going to sit with an answer where x is equal to 4, and the other one is going to give you where x is equal to negative 5 over 2. But this is the other trick or possible place where we can mess it up, because it's not x is equal to 4, it's actually y, but we use the x to work with the formula. So please remember, it's not x, but the y value is actually equal to 4. So now we have y is equal to 4, or y is equal to negative 5 over 2. But you still need to find the x value. So you can sub it into any of the equations. I'm just going to sub it into xy is equal to 20. So where the y value is 4, the x value will be 5. So this answer is going to be y is equal to 4 and x is equal to 5. And then with this one, I just make my y value negative 5 over 2. And then to find the answer, you just multiply with a reciprocal, or you just pop it into the calculator and say 20 divided by negative 5 over 2 times negative 2 over 5. So x is equal to negative 8. So y is equal to negative 5 over 2, and x is equal to negative 8. So you sit with both of those answers. Yeah, we sit with exponents again. So what type of exponents do we have here? It's type 1. So you can go back to the first slide where you will realize it's type 1. And with type 1, what do? We break down into prime numbers and we just multiply. So 4 we can break down into 2 to the power of 2. Take note, there's an n plus 1. At the bottom, the 8 we can break down into 2 to the power of 3. And then in brackets, you put your n minus 1. I always suggest that you then first distribute in the exponent. So that would give me 2n plus 2, because I've seen too many mistakes where someone will forget to distribute the 2 into the 1 as well. 2 to the power of 3n minus 3. Because it's multiplication only, I'm going to take everything up. So this will be n plus 2 plus 2n plus 2. Then the plus 3n you take up, then it becomes a negative 3n. And the minus 3 you take up, so it becomes a positive 3. N plus 2n gives me 3 n's, minus 3 n's, so the n's fall away. 2 plus 2 is 4, and 4 plus 3 is 7. Work it out on the calculator, so 2 to the power of 7 is 128. Now, when you see a sum like this, a little bit of a level 4 type of question, so I would first take you through surds. If you see a square root of 4 times a square root of 4, please take note that because it's the same roots, it's both square roots, you can actually write this as 4 times 4, meaning that you can just multiply the inside and write it as 1 square root. This will be square root of 16, which is 4. Another way of looking at it is that if you sit with square root of the same thing times square root of the same thing, it would just give you 4 as an answer, meaning you can say square root of a number times square root of the same number will just be equal to the number. So let's check it. Square root of 4 is 2, and square root of 4 is 2, and 2 times 2 is 4. Now, if you sit with the same square root, I'm just giving you some more examples. For example, square root of 2 times square root of 3. The fact that it's square roots, but the numbers differ, mean that you can still write it as 1 square root, where you just multiply the inside. So that will give you square root of 6. But let's say it's a square root of a number, and you multiply it with the other type of root, let's say the 4th root of 3, then you can't write it as 1 root. Let's go slightly more complicated or abstract. If I put an x in the middle, and I multiply it, for example, with the x minus 2, I sit with a root times a root, square root times a square root. So what will I do? Because it's the same roots, I can write it as 1 square root, but then you just multiply the inside. So that's what you do. Coming back to this question, I sit with the square root and the square root. So because it's, both square roots, it's not, the one isn't a 4th root and the other one isn't a cubic root, I can write it as 1 root, where I just multiply. I put the inside in brackets. See? So I just put the inside into 2 brackets. Like, for example, this one, where it's not the same numbers, but the roots are the same. So you can just put it as 1 root. Now, I'm first going to FOIL the inside. So FOIL, x times x will be x squared. You can write this down. It does become difference between two squares, but if you didn't see it, then it's fine. Then you can write it down. So it's minus x times square root of 2x minus 1. Then the inside middle will be plus x times square root of 2x minus 1. And then the last, positive and negative, is a negative square root of 2x minus 1 times the same one, 2x minus 1. So can you see the middle terms will fall away? So this will just be x squared minus x squared minus those two brackets, square root of 2x minus 1 and another square root of 2x minus 1. So basically, this will be x squared minus the square of this, 2x minus 1, but it's the square of this. So this concept is pretty much the same as this one, where I sit with two square roots with the same number on the inside, then the answer will just be the inside. Or if you didn't see it like that, then you can just do it like this, where it's the same one squared. So the square root and the square will cancel out. But the inside, you put in brackets. You see how many places here to make a mess. Then this minus, you're going to distribute in. That's going to become x squared minus 2x, and a negative negative is a positive 1. And you're still not done. This you can factorize. So there's a 1, there's a 1, a x, and a x. And if you factorize this, it will be a minus. I owe 1x and I owe 1x. So I owe 2x. So this will be x minus 1 squared. And the square root and the square cancels out. So your answer is x minus 1. That was quite something, wasn't it? Okay, we're nearly done. For what values of x will this be a real number? So let's first think what is real. Real will consist of rational numbers and irrational numbers, both rational and irrational numbers. And non-real is when you sit with a negative inside the square root. So now it's again a level 4 type of question where you must sort of think out of the box. You must analyze the big picture. But let's just go through this quickly. Real numbers is rational. Rational will be everything that makes sense, like a normal fraction. Irrational will be like pi, or it will be a square root that doesn't work out. Rational will be a square root that works out. You can just look under numbers for more of that. Now they ask us here for which value or values of x will P, meaning will the answer, P means the answer, be a real answer, where it's not going to be irrational. So we first analyze the x over 3. Does it matter what the x is? Will it matter? Can x be 0? Yes. If x is 0, it's fine. Even if x is positive 1, then I will sit with a plus 1 over 3. Then my answer is still fine. But what is my biggest problem? My biggest problem is if I sit with a negative number, if I sit with 0 down here. So what must I look at? I must look at this number must not be a negative number. So x plus 2 must not be equal to 0. So x plus 2 must be not 0, it must be bigger than 0. So x must be bigger than negative 2. So if x is bigger than negative 2, this will be a real answer. It says then, show that p will be rational if x is, for example, equal to positive 3. So then you just show what the answer will be. So if x is equal to 3, we sub in x is 3, so it will be 3 plus 2. X is 3, it will be 3 over 3. And this will be 3 plus 2, which is 5. And 3 over 3, which is 1. X is equal to 3. So then this would be 1 plus, what am I doing here? If x is equal to 3, this will be 3 over 3. So this will be 1 plus 1. This one is not working. So that p is rational. So this will be the square root of 1 plus 1, which is 2. And this is not rational. This is irrational. Okay, I suppose the question should have said, show that p is irrational. Sorry about that. If x is equal to 3. Right. Then the last sum here. Calculate the sum of the digits of the number 2 to the power of 2015 times 5 to the power of 2019. So let's see, how would you approach this question? The sum of the digits. So for example, if I sit with 5, 8, the sum of the digits will be 2 plus 5 plus 8, and that will give you 15. Now they say calculate the sum of the digits, but you can't work this out using a calculator. It's not going to help you. So what must you do with this? You must break it up. So what we normally do when we break it up, you break it up working with the smallest exponent. And the smallest exponent here will be 2 to the power of 2015. So I'm going to break this one up, also working with 5 to the power of 2015. And how can I break it up? If I add a 4, because if you multiply the bases, you add the exponents. So then again, it will be 2019 again. Hope you understand that one. What can we do now? I see I sit with the same exponent there. So that means you can actually work backwards. You can write it like this. Remember, I explained this one as my little mad guy. So working backwards, just to show you what I did there. Working backwards, you can just multiply each exponent. You see, you just multiply each one. Okay, so now this would be 2 times 5 is 10 to the power of 2015 times 5 to the power 4. So what is 5 to the power 4? You can actually work it out. That gives me 625 times 10 to the power of 2015. So what is this going to give me? It's going to give me 6250 and you add zeros until you added 2015 zeros. But what did the question say? Calculate the sum of the digits. So we're going to say 6 plus 2 plus 5 plus all the zeros, which will give you 8 plus 5, which is 13. So this is like a level 4 question where you must apply your knowledge of exponents. So please remember, if they do give you like an impossible exponent to work out, you always find the smallest exponent. Thanks for listening.